Welcome to myprojectbazaar.com. The title of the project is Automatic Skin Cancer Detection in Dermoscopy Images based on Ensemble Lightweight Deep Learning Network. And the abstract of the project is the largest organ of our human body is skin, and skin cancer is most predominate type of cancer that influence millions of people per annum. Survival rate of patient decreases steeply if cancer is not detected in early stages. However, early detection of cancer is a very strenuous and costly process. The skin cancer dataset consists of benign and malignant skin cancer digital image dataset. Therefore, identification of cancerous skin lesion in early stages is a difficult matter. In this process, we are going to discuss various technologies that can be used for skin cancer detection and classification and their results. The common approach for early detection of skin lesion is divided into 4 steps. They are follows: pre-processing, segmentation, feature extraction, and classification. In that classification, we are using sparse autoencoder and decoder with deep learning algorithm. Is used to identify the skin cancer disease. It will help to easily identify and detect the early stage of skin cancer. And the flow diagram of the project is: first we need to start the program and select the benign and malicious digital image skin cancer image dataset, and we are going to view the sample images for benign and malicious classes in the console working directory. After that, it will apply into pre-processing method. In pre-processing, we are going to do two methods: segmentation and rescaling method. In segmentation, we are applying YCBR segmentation and also counter detection method, which is used to identify the cancer region in the input images. And I am going to rescale all the images into similar size. After that, we are going to choose the independent variable and dependent variable. After selecting the independent and dependent variable, we are going to split the dataset into training dataset and testing dataset. After splitting, we are going to apply the input to the sparse autoencoder and decoder convolution neural network algorithm and analyze the dataset and generate the results based on accuracy. After that, I am going to predict by manually select one input image, and I am going to find the disease of the images. The program was successfully executed in Anaconda Navigator Spider IDE. This is the sample image visualization of benign classes and also malicious classes. This is our dataset. Our dataset contains two classes. One is benign and another one is malignant classes. And I am going to apply the YCBR segmentation. In that, I am going to read on original image and apply the median filter and apply into HSV segmentation. HSV segmentation will predict the region of the cancer, and after that, I am going to apply the HSV segmentation into counter detection. Counter detection method, it will draw the counter of the cancer region from the input images. After that, I have to check the minimum height and minimum width, maximum height and maximum width for benign and malignant classes, and I am going to provide the label for the benign and malicious classes like zeros and ones. After that, I am going to select the independent variable and dependent variable and then converted it into array. After that, I have to view the sample images for the benign and malignant classes, and this is the independent variable train data and independent variable test data shape, and this is dependent variable train data and dependent variable test data shapes. And after that, I have to apply this sparse autoencoder and decoder with convolution neural network algorithm. First, it will implement the encoding method. After that, it will apply the decoding method. After execution of encoding and decoding method, the convolution neural network algorithm, which is extract the parameter from our input data. So it will extract the parameter of 41,96,738. The overall all the parameters are the trainable parameters. So it will take the data and analyze the images based on the parameters of CNN algorithm. So in that, I have to provide the 25 training epochs, and it will generate the accuracy and validation accuracy of our training images and also our test images, so that the final accuracy of this sparse autoencoder and decoder CNN is 95%. So this is the performance plot of accuracy and loss. So, and this is the classification report. In classification report, we are going to find the precision recall F1 score for benign and malignant classes. And this is the confusion matrix diagram. Confusion matrix diagram, which is used to express the prediction and misclassification of the benign and malignant classes through the convolutional neural network algorithm. And this is the final prediction. In final prediction, we can manually choose on images and predict the image type of disease from the input images by using sparse auto encoder decoder with convolutional neural network algorithm. And these are all the variable results that we are used in our program.